Hey everyone, welcome to problem number 24, swap nodes in pairs. Okay, so it's a medium difficulty one. So given a linked list, swap every two adjacent nodes and return its head. You must solve this problem without modifying the value in the list's nodes. Okay, that is, you cannot just put it in the list and try to swap it. It's basically has to be done by moving up the pointers as well. Okay, just the pointers, that's it. So given a linked list as 1 2 3 4, you have to return 2 1 and 4 3 because we are swapping two adjacent nodes. Okay, what if just the empty linked list? Then we'll return empty, just one head, then we'll just return whatever the head is. Okay, what are the constraints? So the number of nodes in the list is in the range of 0 to 100, so each of them could have 0 to 100, and all the values could be in between 0 to 100 as well. Okay, it's gonna be simple. We'll stick with the two pointer approach as well. Let's start writing up our best conditions. So if not head or not head dot next, then we'll return the head, right? So these two cases are taken care of, and we'll start creating a dummy node. So dummy node would have list node of 0, answer dot next would be current head, and then our current is pointing to the answer, right? So let me give you an example now. So we have 1 2 3 and 4. Okay, now okay, our current node is pointing to 0. Okay, what is currents dot next? It's this one. Sorry, c dot next, and we have c dot next. Just do dot nn just to save some time, right? So what exactly we are trying to do? So let's say, just for the simplicity, we can just take this is t1, this is t2, right? So what we would do right now is, once the nodes are swapped, so how does the swapping work, right? So basically you have t1's next, we'll go to t2's next, basic. Okay, so let me write this. T1 dot next would go to t2 dot next. Where would t2 dot next go? So t2 dot next would actually go from to t1, right? Simple as that. I'm trying my best to come up with the picture here. So t2 dot next would go to t1 basically. So where is current going? So now current dot next was pointing to t1. So now we have to point it to t2, right? Why? Because once this is swapped, we would lose the track of this link otherwise. Okay, so before anything like this happens, so current dot next has to be t2, right? So these needs to be in place. Okay, and once everything is done, so now our current is there, so current goes to currents next dot next, right? So now once everything is done, your current should move ahead in life. Okay, so it would move here. I think it would move here, my bad. Oops, I think it would move here, right to the 1 basically, because we don't want to swap 1 afterwards. It's already been swapped, right? Yeah, I mean I cannot just do it pictorically. if that's a word, but this is what we're trying to do. So what you can do here, so while current dot next and current dot next, so we'll check for next two pointers. T1 is current dot next, T2 equals current dot next, right? And then current dot next goes to T2, just to keep a track. As I said, T1 dot next goes to T2 dot next, T2 dot next goes to T1, and then current goes to currents next. Right? And at the end, what you want to return is the dummy variable is now currently it's just pointing to dummy variable, the answer pointer. We just have to return the swapped head of this, right? I know, just in your free time, try to come up with your own logic. This is the best I could do while explaining it, using the pictures. And it just clears through. So let me see if it works. Okay, 34 milliseconds. That's pretty fast. Yeah, and that's pretty much it to this one. I know people tend to not like linked lists, consider me being one, but me being one of them. But yeah, that's basically to it. Just a couple of pointers and the idea behind swapping up the nodes, and it's already done. Okay, thank you so very much for tuning in. I'll see you guys in the next video. Cheers.